Hello, this is Prof G, and welcome back. This is solution video for question number 7 on our 9-question, 2.5-hour midterm exam. If you're new to this, you can go back and start at the first video, figure out how the exam runs and how I set up and grade the exam. But if you're ready to continue, here's question 7. So question 7 is a Seinfeld alarm where if you attach this to the door, you could hang it off of the door, you could power it by a battery, maybe put it on a hook in a little bag or something like that. And if the door opens, you're going to hear sounds like from the show Seinfeld. There are 3 sounds that show up. It will play one of the 3 sounds at random the first time it detects a sound. So this is how it would work. So the setup for this is, again, if you have a wacky neighbor or a roommate, it'll play the sitcom sounds whenever the door opens and someone walks into the room. So you want to plug in your CPB, and at first the device is not armed, so it's not going to go off. But when you press button A, then you arm the device. Then you'll wait 3 seconds, so that'll give you a chance to sort of set things up, put it in a hook on the door, maybe in a little bag and a hook on the door, let the device settle in, and then it records the last X, Y, and Z position of the accelerometer. Then it repeatedly checks to see if the device is armed and if there was a change in the accelerometer. And if it detects that there is sufficient movement, then I suggest taking a look at the absolute value of 4 in terms of the change of any of the initial values that you had. If that had occurred, then that's a good sign that you've moved rather significantly, that the door may have opened. And it really doesn't matter which position it was in if you go off, if you change by an absolute value of 4 in any of the 3 values, the X value, Y value, or Z value. And if the device is armed and you detect the door opening, meaning you've got one of those absolute values of movements, then wait 1 second so the person starts to go into the door and they can hear the sound, and then play a random sound from the doors folder. And that's either door 1, door 2, or door 3. Then wait 3 seconds after the sound has played, and then you want to reset the X, Y, and Z values with the current accelerometer setting so that you get ready again for the next wacky neighbor to enter the door. So that's how this sets up. You can play the video again if you want to see how it works. It's a fun idea. You can try that out with your friends, or around Halloween you can put spooky, scary sounds that scream when the door opens. Maybe around holiday time you play Jingle Bells. But this is one way that you can implement this and get the solution. So here we need to import digital I/O, Adafruit LIS3DH, and bus I/O. Those latter 2 are because we're going to be working with our accelerometer. And finally, we also need to deal with random, so we need to import that because we're going to get a random sound. Then we import our sound files and we set up our speaker the same way we have before. This is the way that we set up our accelerometer. Again, we learned that in previous lessons. It doesn't really matter the range that you set up, but I stuck with 8G range, which is what we had been using previously. We also set up button A because we use that to arm the device. Now we assume when the application first runs, the program first runs, that armed is set to false. That means it's not armed to go off. We have a list called sounds, which has the 3 names of the sound files in here, and this is the path of our sound file. So door_sounds, make sure that you have the slash at the end too. Now the play sound is very familiar for us. We want to make sure before we hit while true that we get the last X, last Y, and last Z values from the accelerometer's acceleration property. And then as we go through the while true loop, first we check to see if button A is pressed. So that's button A value. If it's true, then what we do is we wait 3 seconds and we set armed to true. Doesn't matter, we could have set armed beforehand, but we want to wait 3 seconds before we get the next accelerometer reading. And we want to make sure that we get that accelerometer reading after 3 seconds so that the device has a chance to settle in. If we just press the button as it sits on a door in a bag, for example, we don't want to get it and then it's still shaking around back there. Now, as we go through after it's been armed, well, what we're going to do is we're going to check the accelerometer value x, y, and z. Now, this is not last x, last y, and last z. So we're checking this each time we go through. And if we have a situation where it's armed and the absolute value of movement between either the last x, the last y, or the last z, and the current reading is greater than 4, and it doesn't matter which axis moves, but if one of them moves an absolute value greater than 4 and we're armed, that means we armed our alarm and the door jiggled, so it must have opened. Then we get a random value from 0 to 2, so those are the 3 different sounds in our sound wave volume, and we wait 1 second before we play the sound, and then we play the sound and our sound list for the random index that we've got, either 0, 1, or 2. Now, in addition to having to get the random index value, you could have gotten rid of that and simply just made a call to play sounds random.choice and then passing in sounds. That would have done the same thing here too. Either one is fine. Then after we play the sound, we wait 3 seconds for the door to close and for things to settle in and the person that's walking in laugh, and then we get a new accelerometer value for the new place where the door has settled at x, y, and z. So that's it. Hopefully your Seinfeld door alarm works well, and you can use this in Halloween occasions and holiday occasions and other occasions as well. I hope you got it, but if you didn't, now you know how to implement it. Go ahead and implement this. Impress your friends. Keep at it. Question 8 is coming up.